Hi everyone, in this video I want to go over a second way to make ethers. If you recall, there are three ways. We went over in the previous video the first way, using two primary alcohols and sulfuric acid to form a symmetrical ether. Williamson ether synthesis, though, gives us an opportunity to make asymmetric ethers. Let me go over a couple of pretty simple examples. Well, first of all, let me just describe in words what Williamson ether synthesis is. What we'll be doing is we'll take an alcohol, make it into an alkoxide by deprotonation, and then take a alkyl halide and form our ether. Now there are limitations as to what alkyl halide we could use, and we'll see that in this first example. We're going to do the deprotonation by, in this case, sodium hydride, but there are many other ways to deprotonate a hydroxyl group. And the alkyl halide that I'll use is a very uncrowded one, so we could do a substitution. Now, let's just understand what's happening in each step before we draw a product. This is for deprotonation, because we're using a base. And here we're going to do an SN2 type of substitution. This is the product, and here's your methyl group. That oxygen, which used to be an O-, attacked the carbon of the methyl halide. Okay, so let me just write here that alkyl halide either has to be a methyl halide like we used here, or an uncrowded, primary alkyl halide, which is uncrowded. Okay, let us attack another alkyl halide. Maybe that's a primary alkyl halide. And also, let me show you that the stereochemistry should not be affected. For instance, let's take that. In the alcohol chapter, we learned that you could use just plain metal to do a deprotonation. And the alkyl halide I want to use here is 1-bromopropane. Why don't you pause the video and draw the product here, and when you unpause it, make your corrections in a different colored pen. Okay, we have this alkoxide, so that was an O-. It attacked this dot to kick out the bromine in an SN2 reaction. Dot. And again, this is SN2. Should I go over the mechanism? Let's do the mechanism for this one here. I don't teach the mechanism of this deprotonation step where you use a metal like sodium or lithium or potassium, but in this case, you should know the mechanism. The hydride is going to grab the proton. Okay. You may be able to do this on your own, or if you want to try it on your own first, go ahead and do that. Okay, in the mechanism, you take an alcohol and deprotonate it to make the alkoxide. That alkoxide is what? A strong nucleophile, strong base, and when you are paired up with a uncrowded alkyl halide, like a methyl halide or primary alkyl halide, then you will mainly do substitution, and it will be SN2. Okay. Now, what is this limitation all about? Well, like I said, this molecule here when you learn about substitution and elimination and the factors that go into deciding what this will be, either a nucleophile or a base, it depends on the alkyl halide. Because if you are reacting it with a primary alkyl halide, right, just like we did here, or well, that's actually a methyl halide, but here, a primary alkyl halide, then you will favor SN2. And let me do that. Let me make it like this. It's still primary, and we have this. SN2, but as the alkyl halide gets more crowded, for instance, if we have secondary, then we will have some substitution. Okay, substitute at this dot. That's SN2 for sure. But also we would have elimination. And we would get, actually, because this is a strong base, we would get several products. Okay, and all of those are E2. In this case, this is the major product. And actually, let me draw the E2 product for this alkyl halide, for this one right here. That's E2. Do you remember this exercise where when you have a strong nucleophile, strong base, it depends whether your alkyl halide is primary, secondary. And just to finish out the trend, if it's tertiary, it's all E2. It's all E2. And only E2. One product. Okay. Again, the purpose for this chapter is, or this video, is to make ethers via a Williamson ether synthesis. You notice that we cannot do it with a secondary alkyl halide. Pretty simple. Let me give us a couple more examples, and I do have a synthesis type of question for you all. But before we do that, I think the reaction is pretty straightforward. It's just you want to do a lot of examples so you get used to the different types of bases that a person can use, like potassium terbutoxide. It's a strong base, it's a strong base, and we're going to remove this proton. Okay, we're not doing what? We're not doing elimination, because in the alcohol chapter you need the strong acid to make this a good leaving group to do elimination. Anyway, let's do this alkyl halide. Again, I'm going to make sure that it is primary. Alright, go ahead and do that. Let me give one more example. There really is not a huge limitation on the type of alcohol you want to start with. It could be primary, secondary, or tertiary. And let me give you one more base. You know this one. And just for practice again, let's use a methyl halide. Pause the video, and when you unpause it, I'll do these two for us. Okay. You make the alkoxide. Okay. So I'm not doing the mechanism, but visualize an O-. attacking this alkyl halide at the dot. We have a CH2 group, and then the ring. So there's your CH2 group, and then the ring. Or you could say we have two CH2 groups, one here, one here, one here, one here. And that is the major product, because I'm going to remind myself that this is a primary alkyl halide. This one is a methyl halide. And quite simply, we have this product, Williamson ether. So what is the synthesis that I want us to think about? Propose a synthesis from an alcohol to make this ether. Well, the thing is, we could either make this bond using an alkoxide that looks like that, or we can make this bond using an alkoxide that looks like that. Okay. Which one is better? Or are both doable? Okay. So the analysis is, if I try to make bond A, I would be using, go ahead and take a note card or a post-it note and cover it up. If I want to make bond A, I got to use that alkoxide to bond to that dot right there. And that was an alkyl halide. Okay, an alkyl halide. All right. So, let's see. I already forgot which alcohol. I need this alkoxide. Again, we're making bond A to attack this alkyl halide. Okay, just see how that comes together. But if we try to make bond B, I don't know if this is as good. We take this alkoxide to make a bond to this dot right there. This alkoxide. Draw my dots. And so the BR was on the dot. We notice that this is secondary. And we're not going to get a substitution product as a major product. We're going to get the elimination and make a double bond from this alkyl halide. That's the strategy. Okay, so we're going to reject this. And this is good because this is primary. We just now have to format it in a synthesis. And it says synthesis from an alcohol, not from the alkoxide. Okay, there's your alcohol. What base do I want to use? I like NaNH2. We shouldn't use OH minus, right? Because if we use OH minus, the conjugate acid of OH is water, which has the same pKa or similar pKa to this. So the equilibrium is half and half. But here, right, we make a conjugate acid that's very, not very acidic, right? So for synthesis, you don't have to draw all the products, just the main product, but let me prove to you that this is a strong enough base. That has a pKa of 36. This has a pKa of 15.5. Equilibrium favors the weaker acid. Okay, so we get a lot of this alkoxide. And what was the alkyl halide we want to use? We want to use that one. And again, we are formatting it in a synthesis fashion. Dot CH2 1 2 3 4 5 1 2 3 4 5. That is Uh-oh. What happened here? We're making bond A. Did I copy this wrong? Oh, no. It's correct. It just got flipped. Because here, which bond did we make? We made bond A, and now bond A is on the right. Ooh. Okay, good. Those two are identical. Now, think about this. Maybe in a longer synthesis, they don't ask you to draw it from the alcohol. Maybe they say draw it from an alkene. Well, nuts. Maybe this alcohol came from... So this is the answer. But what if I said start from an alkene? Maybe this will work, right? You take this alkene and you... We're going to do a hydration, but we have to put it on this carbon, not on the more substituted. Do you remember this reaction? Hydration, but in an anti or non-Markovnikov fashion. This is hydroboration oxidation. Okay. Again, the question was to make this alcohol, make this ether from this alcohol, ether, and we rejected making bond B, but we are good with making bond A because you attack a primary alkyl halide.